Hello, welcome back. We are covering 2.3, getting information from the graph of a function. This section covers 4 topics. We are going to break up this section into 2 parts. So this is 2.3 part 1, and we will cover the values of a function, domain and range again. And comparing function values and solving graphically. So we're going to be using the graph to determine all kinds of pieces of information. Okay, and then in part 2, we will take a look at increasing and decreasing intervals of a function and the local maximums and minimums of a function. Okay, so 2.3 part 1. So here, we are going to be looking at a graph, and you might be given a graph and you're asked to find certain values. So for example, here they might say, okay, well, go ahead and find f of -2, f of 0, and f of 1. And normally you guys would take those x values, -2, 0, 1, and you would plug them into a function, work out the calculations, and come out with some y value, right? Okay, so we don't have a function written out here for us. However, we do have its graph. And so what you do here, instead of plugging into a function, is you take a look at the graph of the function, and you look at this x value, -2, which is over here, and you check to see what its y value is. So we see here that f of -2 is 4. Okay, so -2, when x is -2, we get 4. Okay, so here f of -2 would equal 4. And then f of 0, so x is 0. So when x is 0, we see that y is 0. So here, f of 0 equals 0. And then for this one, x equals 1. So we go to x equals 1, and the y value is 1. Okay, so f of 1 equals 1. Okay, so that's how you would evaluate a function using its graph. Okay, so you just go to these x values, -2, 0, and 1, and you find their respective y values. -2, we get 4. 0, we get 0. 1, we get 1. Okay. All right. When it comes to domain, well, I guess it's not really well, never mind. I'll just call it part B, domain. So here, when they ask you for a domain, they're asking you for the x values that are being used for this function. Okay. And so we see, so that's our horizontal. Okay, so we want to know what values horizontally, what space is being used to create this this graph of this function. And we see these arrowheads, so this goes on forever and this side goes on forever, and it gets wider and wider and wider. Okay, so we can see here that all of the x's are getting used. So our domain is all real numbers, and we can represent all real numbers by doing this. Okay, -infinity to +infinity. Okay, so again, domain is our horizontal space, okay, that's being taken up when we look at it visually from a graph. Okay, whereas range, when we look at the range of this graph, this function, then we're talking about the vertical space, right? And so while here, let me go ahead and draw it out. So here, our domain is our horizontal space, and we see that all of it is being used horizontally. However, when we talk about our range is our vertical space, right? So our range is our vertical space here, and we don't see we don't see all of the y values being used. We don't see these y values here being used with this function. We only see this top part being used, right? So when we're talking about our range is really only from here. Let me use a different color to highlight it. So our range is really, and let me go thicker. Actually, let me use this. Okay, so our range is really this part here, right? So we see only these y values are being used, right? We don't see the graph down below over here. Okay, so we don't see the graph being used down here. We only see the graph being used up here. So our range is going to be everything from here on up would be our range. Okay, so from here all the way up is our range. So we would say from 0 to positive infinity. Okay, sometimes I think, most of the time I use positive infinity. You don't have to. It's just a habit I'm trying to break. Okay. Okay, so that's how you find, that's how you evaluate functions using a graph. That's how you find the domain, by looking at the graph, looking at the x values that are being used. And that's how you find the range, by looking at what y values are being used. These y values are not being used. We don't see the graph down here. We only see the graph up here. So only these y values from 0 all the way on up are being used. Okay? All right. So let's take a look at this next example. We'll do one at a time. Okay, so here for A, suppose that you had to find f of -6, f of -3, f of 0, f of 3, and f of 6. Okay? All right, so let me go ahead and see if we can scroll in here so we can see this. All right, so we'd have to go all the way to -6. So 1, 2, 3, 4, 5, 6. So here's -6, and the point, the y value that it's associated with is 1, 2, 3, 4. Okay, so to save space, I'm just going to write an arrow. F of -6 is 4. Okay, f of -3, so then we would go to -3, 1, 2, 3, and it lands right over here on the graph. So f of -3 is 2. 1, 1, 2. Okay. And then f of 0, here's 0, is 1, 2, 3, 4, 5, 6. So f of 0 is 6. F of 3, 1, 2, 3, is 0. And f of 6, 1, 2, 3, 4, 5, 6 is at 1, 2, 3. Okay. And then let's do net change. Let's see if you guys remember net change. So we did that. Let's do the net change from 0 to 6. Okay, so if you remember net change, we have to go in order. That would be f of 6 minus f of 0. Make sure you go in the correct order. Okay, so let's take a look. F of 6 we see is 3. Okay, you can see it graphically, but you also found it here. Okay, f of 6 is 3 minus f of 0, which is 6. So we get negative 3. Okay, so the net change from 0 to 6 is negative 3. Let's get the domain and the range. All right, so here the domain are the x values. So let's take a look. So we have endpoints here. So our domain doesn't go on forever to the left, and it does not go on forever to the right. So it ends right here, but it's everything for our domain is being used in the middle here. Let me change colors here. All right, so we see our domain is from over here all the way to here. So our domain is going to be from negative 6 all the way to positive 6. That's going to be our domain. Okay, so let's go ahead and write that down below. So it's going to be from negative 6 to positive 6. And we use brackets because they are closed points. If these were open points, like you have here, then you cannot use bracket. You have to use parentheses. Okay. All right, range. Let's go ahead and find the range. Let me write that down here. Okay, so the range of this graph here. So again, let's use a different color. I will use purple. Okay, and so here, our range, this is the lowest point right here, okay? And the highest point is right there. So this is going to be our range, okay? All right, so this represents our range. And so that looks like it goes from 0 all the way up to, what is that? 1, 2, 3, 4, 5, 6, all the way up to 6. Okay, so let's go ahead and write that down over here. Our range is from 0 all the way to positive 6, including. Okay. All right, so let's go ahead and have you try the graph of B. Let's see if you guys can find the following. Okay, go ahead and see if you can find f of negative 7, f of negative 4, f of 2, and f of 5. Okay, so go ahead and hit the pause button and come right back and see if you have the same answers. Okay, so f of negative 7, here, maybe you need to see it like this. Okay, so let's do that. Okay, so if you needed me to zoom in to answer this, go ahead and hit the pause button now and do the problems. Okay, so f of negative 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So f of negative 7 is negative 3. F of negative 4, 1, 2, 3, 4 is 1, 2, negative 2. F of 2, 1, 2, 0. And f of 5, 1, 2, 3, 4, 5. Okay, so you might, okay, so that line is they drew it kind of incorrectly. This is clearly an open circle that they're trying to say, but they couldn't quite get the line to end here. So really, when you see this open circle, there's nothing there. There's no point there. So here, you really should say undefined. Okay, but if you said 1 because you felt like this graph was a little unclear, that's fine because it is a little unclear. The graphics, but on your homework problems, there won't be any ambiguity. Okay, try this. Find the net change. Let's do that. Go ahead and find the net change from -4 to 2. -4 to 2. Okay, so again, make sure you do it in the correct order. -4 to 2. Okay, and hit the pause button and come back and see if you get the right answer. Okay, so f of -4 and f of 2 are what we need. And we need to do f of 2 first. F of 2 minus f of -4. And that is going to be f of 2 we said is 0 minus f of -4, which is -2, which is 2. Okay, and let's just kind of compare these two. So we see here, that way you can kind of check your answer to see if it looks correct. So like over here, from 2 to -4, okay, oops, that's it. That's supposed to be, yeah. Okay, so the net change from -4 to 2, so -4, 1, 2, 3, 4. So down here, all the way to here, that's here to there is an increase. And then over here, if you notice, from 0 to 6, here's 0 to 6. And so even though it does more than just go in one direction here, from 0 to 6, the end result is still a decrease from 0 to 6. Okay, so that's still a decrease, so that's why you have a negative number. And over here, from -4 to 2, that's an increase. Okay, so that's why it turns out to be positive. Okay, and go ahead and find the domain and the range. I guess that's not really a C part. Okay, so go ahead and find the domain and go ahead and find the range. Okay, so go ahead and I'll zoom in there. Go ahead and pause and come right back. Okay, so here I'll go ahead and use some colors. All right, so our range, our domain, we'll do domain first. Okay, so our domain starts from here and goes all the way to here. These are all the x values that are being used, except this one is open, so we won't use a bracket, we will use parentheses. Okay, so we see here that our domain, the x values that are being used, are going to be this one here, which is 1, 2, 3, 4, 5, 6, 7, -7, bracket, -7, all the way to 1, 2, 3, 4, 5, all the way to 5, except we're not going to include 5, so we're going to use parentheses. Okay, so let me write that down. Okay, domain is -7 to 5. So that's what you should have gotten. And then for the range, let's have a look. I will use purple. All right, so it looks like our range is from here all the way to here. Those are the y values that are being used. And so we can see here that our range is, what is that? Negative 1, 2, 3 included, all the way up to 1 not included. Okay, so that's our range. Let's go ahead and write it down here. So from negative 3 all the way to 1, but not included. Okay. All right, very good. Okay, let's go ahead and take a look at this next one. Okay, so go ahead and try this one. See if you can find the domain the x values are being used. See if you can find the range, the y values that are being used, and see if you can find these values. Okay, and then bonus if you can find this. Okay, all right, hit the pause button and come right back. Okay, so the domain here, we can see. I'll use red again. Okay, so our domain goes from here all the way to here, but that's an open point. That one's clearly an open point, so you shouldn't have any problems figuring that out. Okay, so this one's our domain. Okay, and that looks like it is from negative 3, and we include the negative 3, all the way to 2, but 2's not being included. Our range, okay, so our range, oops, I wanted to use this one. Okay, it goes from here all the way down to here. Those y values are being used for our range. Okay, so that looks like it is from negative 5 included all the way to 4 also included, because up here the highest y value that's being used is this one, and that is a closed point, not an open point. Okay, so all of these y values have a point on the graph. Up here they have 2 points. Okay, 1 point. Okay, all right, f of negative 1, here's negative 1, and looks like 3. F of 2, there's an open circle, so this is undefined. F of negative 3, down here, goes to negative 5. Okay. All right, so this is a interesting question. X values where the function is greater than 0. So for what values, for what x values is our function greater than 0? Okay, so here it's at negative 5, so not there. Negative 4, no. Negative 3, no. Negative 2, negative 1, no. 0, kind of close. Okay, so starting from here, okay, so here, let me get some colors going on here. All right, so I'll use yellow. All right, so we see that here, this part of the graph, is where it is above 0. Okay, so this is the part of the graph that is greater than 0. Okay, so let's go ahead and describe those x values. Okay, so those x values would be from negative 2 all the way up to positive 2. But not including negative 2 and not including 2, because we want to be strictly greater than 0, and at negative 2 it equals 0. Okay, we want to know where the function is greater than 0. Okay, so above the x-axis. Okay. All right, good. And let's see. Okay, so comparing function values, solving equations and inequalities graphically. Okay, so let's go ahead and label these functions. So this, we're going to let this purple one is going to be f of x, and this inverted parabola will be g of x. Okay, so the purple one is f of x, the dark green one is g of x. Okay, so it turns out this is just a little definition here. So let's put a note here. F of x equals g of x at x values, where the graphs intersect. Okay, so at the x values where the graphs intersect. So when we look over here, we see that these two graphs, this purple pinkish graph and this dark green graph, we see that they intersect right here and right here. So let's try to identify the x value. So this one looks like it's at 0.5. Okay, so here f of x equals g of x at x equals 0.5. And then the other one would be here. And that looks like, I'm not sure, 4.1, 4.2. I'll just say 4.2. Okay. If it's off like that, if you say 4.1, that's fine. Something close to 4.2. But if you say 7, yeah, clearly that's off. Okay. And then over here, f of x is less than g of x at x values where f is lower okay, where f is lower. So in this case, here, where f is lower. So here, f is above g. So f is higher than g, greater than g. But over here in this region, the pink graph is below the green graph. So here, right inside here, where the pink graph is below the green graph, f of x is less than g of x. Okay, so for these x values. And then all of a sudden over here, the pink graph is above the green graph. Okay, so here f of x is less than g of x in this area right here for all of these x values. So we can, instead of like saying one particular value, we can go ahead and say this interval from x, what is that, 0.5 all the way to here, 4.2. Okay, so f of x is less than g of x on the interval from, don't include the 0.5, so on the interval from 0.5 to 4.2. And again, don't include the 4.2 because that's where they are equal, but we want strict inequality. Okay. All right. and then on these other places, f of x is greater than g, starting from here, which is negative infinity all the way to 0.5, together with all the way from here, which is 4.2, all the way to positive infinity. So let's do that. And then note f of x is less than, greater than, let's do greater than equal at x values, where f of x is greater than or equal to g of x. Or here. Let's just say this, where f is greater, is higher. F is higher. So in this case, over here, that would be from negative infinity to 0.5, together with 4.2 to positive infinity. Okay, and the reason why I can use brackets now is because I don't have strict inequality. I have greater than or equal. And remember, where they intersect is where they are equal. So that's why I include 0.5. That's why I include 4.2. Whereas here, this is strict inequality. So I cannot say this is true at 0.5 and 4.2 because this is not true. At 0.5, they are equal, not less than. Okay? All right. Go ahead and try this. So if you can't see that, the blue function is f of x, and the red function is g of x. Okay, and what I want you to do is I want you to answer these. Okay, so A, which is larger? Which is larger? F of -1 or g of -1? Okay. And then B, which is larger? Which is larger? F of 3 or g of 3? Okay. And then C, for which values of x is f of x equal to g of x? Okay. Oh, you know what? I have it written down here. I'm so much better than I thought. Okay. Except I left all this white space. That bothers me. Okay. All right. So you have the questions over here. Which is larger? Okay. So since, let's do 2 questions at a time. That way I can zoom. Okay. So which one is larger? Here, maybe we have to do 1 question at a time. Which is larger, f of -1 or g of -1? Okay, so f of -1 or g of -1. And remember, the blue one is the f function. Here, maybe you guys need to see it. The blue one is the f function, and the red one is the g function. Okay, so which one is larger, f of -1 or g of -1? Okay, so hopefully you said which one is larger? The one up here. So that would be g of -1 because g, the red function, is higher. So this one would be g of -1. Okay, what about B? Which is larger, f of 3 or g of 3? So here's, oops, here is 3. So the one that's higher is the blue function, which is f. So you should have said f of 3. Okay, and then for which values of x is f of x equal to g of x? So where are they equal? Okay, so where are they equal? Remember, they're equal where they intersect. And you just have to give me the x values. Okay, so you should have said at this x value, this x value, and this x value. Okay, so at x equals 0, x equals 1, and x equals 2. Okay, and find the values of x for which f of x is less than, lower than g. So f is the blue function. So where's the blue function lower than the red function? So f of x is lower over here, but not in here. Lower in here, but not over here. Okay, so we're going to say from negative infinity to 0, and then from 1 to 2. Okay, so the blue function is lower than the red function from negative infinity to 0. And then the blue function is also lower than the red function from 1 to 2. Okay, so let's go ahead and write that down. So from negative infinity to 0, we can use bracket because we have less than equal, not strict inequality. And then from 1 to 2. Okay, and find the values of x for which f of x, the blue function, is strictly greater than g of x, okay, the red function. So where is the blue function higher than the red? So when we look at this, blue function higher than the red function right in here from 0 to 1, but not here, and then here from 2 to infinity. Okay, so 0 to 1 and 2 to infinity. So, and this is strict inequality, so no brackets at all. 0 to 1, and then from 2 to infinity. Okay. All right, so that is it for part 1. Stay tuned for part 2, where we look at increasing and decreasing functions, maximums and minimums. If you have any questions, make sure you message me or email me.